Good morning. I am Dr. Yogesh, Professor and HOD, Department of Physiology, Sri Chamundeshwari Medical College Hospital and Research Institute, Chandpatna. Good morning, everyone. So this is a small attempt to revise all the practical experiments just before your final exam. We will try to concentrate not on the entire procedure, trying to see the key points in every experiment. Let us start first with the hematology section. So the first experiment is the RBC count. So in the RBC count, first thing compulsorily you have to know is the name of the diluting fluid. So for every hematology experiment, you should know the fluid what we are using, what is its composition, and what is the function of each of the component. For example, in RBC count, we use the Ames fluid. This contains sodium chloride, sodium sulfate, mercury chloride, and distilled water. What sodium chloride will do? It is going to maintain the isotonicity. So how this is going to help? Because of this isotonic media, the cells are neither going to swell nor going to shrink. Because if the cell starts swelling, what will happen? The cell can burst and totally disappear from your count. So to maintain the isotonicity is very important. Sodium sulfate, what that will do? It is going to prevent Role formation. We pronounce it as Role or Rolu formation. It is preventing it because we don't want all the RBCs to stack on each other and it becomes difficult for us to count. Mercury chloride, what it is going to do? It is going to maintain antiseptic condition, or it is going to act like prevent the growth of any fungal organisms into the fluid. This doesn't mean that when you are counting the cells, some organism will start entering and start eating your RBC. Not like that. When your RBC solution is stored in the storage for quite some time, we don't want any organisms to grow in that. So that is what your mercury chloride will help you. And finally is the distilled water. So distilled water is going to act as a solvent. Okay. So the next thing is, I hope you are very familiar for identifying the RBC pipette and the WBC pipette. Okay. The key points here are, you can appreciate the markings. This is the first thing. 0.5, 1 and 101. That shows this is an RBC pipette. Other points are, it has a red color bead and a red color mouthpiece. Always there is a probability that mouthpiece could get changed also. So only for that reason we have to see the markings on the pipette. So in the WBC pipette, you can see the 0.5, 1 and 11 mark. The bead is white in color and the mouthpiece is also white. Why I told the markings are important is, over a period of time what will happen? The white bead the color can change. When we keep on repeatedly using it, color can change. So the bead and the mouthpiece also can get changed. For that reason, better not to go with those two, go with the markings on the pipette. And another very common mistake done by most of you is when you see the counting grid. Let me explain. We'll go to the counting grid. In the counting grid, we know that there are 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the nomenclature. The box number 1, 3, 7, 9. This is used for WBC, counting the WBC. Whereas the central fifth box, it is again subdivided. You can see this is made up of the medium squares. If you count, there are 1, 2, 3, 4, 5. So it is 5 into 5. 25 squares are there. In this, upper left, upper right, lower left, lower right, and the middle. Only these squares are used for counting the RBCs. Okay, and one thing, because we see that students, you get confused when you're counting the RBC and WBC. We have seen that students are counting RBCs in the WBC square. So the entire calculation will go wrong. We cannot do like that. We have to stick whatever the standards have been set. We have to follow those guidelines only. Another common mistake what many of you do is whenever you are counting RBCs, it is should be in the high power, and whenever you are counting WBC, it should be in the low power. Okay, so these are the quick instructions about the RBC. So after that, after these basic precautions, the other things are you should definitely know what is the normal count, and what is the normal count in the male, what is the normal count in the female, what is the reason for this difference. If the count is more than the normal, what do we call, what do we suspect, in which all conditions we see that. If the count is below the normal, then what do we call it, in which all conditions we are going to see these things. So these are very basic things compulsorily you have to know. The other questions what you can come across is it all depends on what you are going to answer. Let us say, for example, if you get a question in which condition the count is less than the normal, when you say anemia, the discussion can go further in the anemia. Okay, so in the practical examination, mainly what will be seen is your practical skill, how nicely you are performing the experiment, and a little portion of marks will be allotted for your theoretical knowledge. So that is about the RBC count. Thank you.